meteorologist astronomer Dr. Salman Hameed, Mr. Universe, at your kitchen table here in Amherst for some kitchen table astronomy. We landed on the moon!
Yes, a little. I would say we limped our way to the moon.
We trip landed on the moon.
That is correct. Yeah, so it was, and by we mean by the U.S. landed on the moon for the first time in 50 years, roughly in 50 years. Last time was Apollo 17 in 1972, and this time it's a private company, Intuitive Machines, that landed a spacecraft basically on the moon.
Maybe not too intuitive because it ran into some problems, which I'm sure we'll get to. But
yeah, so this is one of those things where it reminds you how difficult it is to still land on the moon. People go like, "Oh, we've landed on the moon. How hard would it be?" Well, it's still very hard, and many missions. There was a Russian mission that failed. More recently, the Japanese mission that tilted on the side as well. There was an Israeli mission that had failed a while back, but there have been some successful landings as well. Indian mission Chandrayaan that landed last year, and Chinese missions have been very successful. And so it just tells you the record is roughly, I think, 50-50 in terms of what you land. So you cannot yet, I think, want to send humans there with a 50-50 chance. Hey, you're going to make it or you may not.
Well, why is it 50-50 when we did it, allegedly, so many times in the Apollo program?
Well, first of all, it's a newer systems that they are using. And secondly, even with the Apollo program, the first Apollo 11 landing actually was tricky because you have boulders over there, you have sort of like terrain over there, you have craters. And so you really have to figure out how are you going to maneuver at a place, by the way, which doesn't have any atmosphere either. Mm-hmm. So when you are going down, you are really maneuvering without an atmosphere, using your burns for the rockets over there. And Neil Armstrong famously, right towards the end, they were thinking about aborting that particular landing because they had gone a little bit off course. And then he took over manually and landed that particular one. In this case, the Intuitive Machines, so there is a lot of effort. How do you automate? So meaning to say, rather than controlling it from the Earth, because it still takes a little bit time to get what you are seeing and to react to that, can there be a way that the spacecraft itself judges where you are going and what is the best place? Because as you are coming down, you have to really figure out, hey, there is a little rock that you may actually land on it and you may tip over, for example, right? And in this particular case, the one Intuitive Machines one, they had a radar, basically a type of a radar that actually maps out how far away you are from the surface. That's an important component. But right towards the end, they found out actually like a day before or even less than that wasn't functioning properly. And so they actually were really worried about how they are going to do the landing, but the spacecraft was also carrying some payload, including 6 experiments from NASA, or 6 instruments. And one of them was an experimental thing to actually do this type of measuring how you're going to the terrain and stuff like that. So actually they used the payload that was on the spacecraft. They had to switch it on and use that. And they actually extended the landing, I think, 2 hours. There was a 2-hour delay because in order to do that, this is where some of the cool stuff comes in. They actually had to upload a new software patch because now they were using a different one to land. And so on the one hand, you go like, hey, the other thing didn't work. I mean, they forgot to switch it on. Apparently, some safety switch was on for the original laser for the distance measurement stuff. But the one they ended up using, they were like, hey, we have that. But then they had to send a software update. And in order to do that, apparently, it took some time to figure that out. But they ultimately did. I was watching it live stream for that. And in some ways, it's a little anticlimactic because you're not seeing sort of like the live feed from the spacecraft. You are seeing people live seeing the instruments of what's happening. And it was like, okay, well, they've landed, and now they go like, okay, now we have to wait until the spacecraft sends you back a signal. And here there was a delay, and it was a longer delay than they expected. And then finally it came in, and it was like, it's a little bit of a weaker signal, but okay, we have landed. And then everybody had to clap and things
It's
like
always fun to watch those nerds in like mission control clapping when something lands. I love it. I get all emotional.
Absolutely. And so it turns out what happened in this particular case is that this lander Odysseus, it's actually pretty big. It's 14 foot tall. And I should mention one other thing regarding this is that this is also a landing close to the lunar South Pole. This is the farthest landing in the South Pole that humans have ever done. And so this is, again, tricky. And the reason why we are going to the South Pole is because that's where there are these permanently shadowed regions, meaning to say there are places where the sun doesn't shine. No, not that. But this is where there is water ice. And so both the American-led Artemis Alliance and the Chinese-led Alliance are both planning on having a permanent base in the lunar South Pole, and so people are trying to go there. And so, in order to have a base, first you have to land there, and so this is one of those things. So they were planning on doing that, but the lander itself is like 14 foot tall. So we're talking about a big lander, Odysseus, and it turns out it has 6 legs, and they think what happened was one of the legs got tripped over while coming down, and that's why it fell on its side. It's still working, and
But it's lying on its side on the moon.
a little bit, yes. They're still figuring out information, more information about it.
Its solar panels are still working. All the other good
It's all
stuff.
charged up. It's like if you had
It's lying on its side. It's relaxing on the moon.
Yeah, I mean, like, it's like its cell phone is still working because hey, that's all charged up. It's a little sideways. Interestingly, they did have another payload. It was called Eagle Cam. This was designed by students at Embry-Riddle Aeronautical University. And originally the plan was that as the spacecraft Odysseus, the lander is coming down, it would actually spit out this Eagle Cam, and it's going to go out of the spacecraft and then take pictures of the landing.
That's cool.
And that's what everybody was expecting. That would be really cool. But because of all these navigational problems, they actually didn't take it out. So that's one of the reasons why we don't have amazing pictures of the surface. Other than that, I think they released one picture, but we don't have more pictures from it. However, they do think that they are going to actually still get the Eagle Cam out, and then we will have some pictures from the ground.
We can have pictures of Odysseus lying on its side on the moon, which would be fun. Montague Community Television used to have an Eagle Cam that was a camera in a bald eagle's nest on Barton Cove. And you could watch on MCTV what the eagles were up to. And sometimes they'd like bring a cat into the nest, and they were like, we got to shut this camera down.
Not a cat.
Yes. Eagles will eat anything. So people were like a little bit freaked out by it. And then there was some destruction. I think a storm took down the Eagle Cam, but that's a different type of Eagle Cam.
Okay, all right.
Equally as cool.
And UMass has one too, right up on top of the
there's a falcon
library. The Falcon,
on
yeah,
top of
Falcon
the
Cam,
library.
yeah.
God rest the owl of New
yes,
York City
please.
that passed away too. People love that owl.
That is correct,
Yeah.
and sad because the way it passed away. I mean, like, you go, owl passes away, that's fine.
Yeah.
But it hit a building, so
Yeah, right.
that
It
glass
choked on
over
the
there.
Tootsie Roll center of a Tootsie Pop. Do you remember that commercial? Anyway.
So, again, a couple of things regarding that. The spacecraft is going to be, even though it's charged, it still has about roughly 2 weeks, less than that, about 10 or 11 days, until the nighttime starts over there. And when it's night, it's very cold, and the equipment is not designed to work in those conditions. So they will have to do all the science in the next 10, 12 days. And so there you have it. But this is just the beginning, because just recently, last month, one of the missions failed. That's the Astrobotics that was going over there.
And that was another private
American
partnership
mission
with NASA, right?
And then the Japanese mission, which was called SLIM. The explicit purpose for that was to make an accurate landing. And they actually did end up, even though it's on the side, but it turns out that it actually landed within a football field range, which actually is amazing because, again, if you are planning on sending humans or others, your landing has to be really accurate. Or if you are sending material to cargo for astronauts or for the base, it has to be really accurate. And so a slim spacecraft for Japan, that actually worked it pretty accurately. And now you are going to have a lot more missions. There is a Chinese mission, Chang'e 6, and that's a really exciting mission because China is the only country to have made soft landing with a rover on the far side of the moon. And now they are planning on returning samples from the far side. We've never had samples from there. This would be incredible. And as you can imagine, far side, because that's the side which Earth never sees, that is hard because you cannot communicate directly from Earth, but instead you need actually a relay station in order to communicate from the far side. And China was successful before, and with Chang'e 6 mission, that is what they are hoping to not only be there, but then the spacecraft is going to launch from the far side and then come back to Earth.
Wow.
And Intuitive Machines, I think, has one more mission planned this year. So there's a lot of stuff that will be happening. And from astronomy perspective, I should mention that this particular Intuitive Machines mission also include a couple of astronomy things because there is sort of like, because the far side of the moon in particular would be great for radio astronomy, for example. So there is an instrument that actually looks for what kind of interference you might be seeing, for example, from solar particles, because there is no atmosphere on the Earth, so everything comes in. How much interference you would get for radio astronomy and things like that. So moon can open up new kinds of avenues. So even though, and we've talked about it, we have a lot of reservations about the pure commercial nature of that. Nevertheless, you also have benefits in particular for the type of astronomy, the type of science you can do from the moon, which you cannot do from other places. And in fact, there is already some conversation about how to protect the moon for science purposes. That if you have construction or if you have other things going on, is it going to disrupt sort of the potential for using moon for astronomy, including the problem that we are facing here on Earth, and that is all these satellites here on Earth. Same thing is going to start happening on the moon as well. So astronomers are being a little bit more proactive about that.
All of this public-private partnership with NASA, all of this with the Chinese, all of this with the Japanese and Indian as well, all leading up to permanent bases on the moon.
Yes, and Artemis program, this is the American Alliance, they are planning on sending humans back. I mean, I think the humans with an orbital program or mission, that is, I think, in the next year or so. They thought of 24, but that has been postponed, I think, at least till 25, if not 26. And then after that, the third one is supposed to expected to get down on the moon, on the surface of the moon in the lunar South Pole. And so is the Chinese. The Chinese Chang'e, I forgot which one it is, but they are planning on having other missions to the moon to get more information about it. They're going to be going to the South Pole as well, but ultimately there are plans to land taikonauts. So those are the Chinese astronauts before 2030 or around 2030.
Does this all feel like Hollywood and how we just like to remake movies? Like, we already did this 50 years ago when we landed people on the moon. Why is this exciting? Why is this something we should be pursuing? Well, like, I know Dune was great with David Lynch, but maybe this Dune.
And we are going to talk about that. We are going to talk about next week.
We got to talk about Dune.
I'm excited about Dune. But there are a couple of things. First of all, the first time humans went to the moon, there wasn't much scientific motivation for that, or even commercial motivation for that. It was really driven by the Cold War, and so
listen to the Moonrise podcast from the Wall Street Journal. Unbelievable, excellent podcast.
Really fantastic, and so it was really driven by that. And now there are other reasons why humans are going.
Actually, it's Washington Post, isn't it?
It's Washington
Yeah,
Post.
Moonrise Podcast from the Washington Post.
Yes. And so the reason why we are going back now, there are potentials, again, as I mentioned, from purely science perspective also. Technology has gotten cheaper, so you can do a lot more stuff on the moon. But also there are commercial interests. And this time it does look like that the moon is not, it's not the final destination, but rather it is going to be a place with which humans can plan from trips to Mars and beyond. All of that said, it sounds that, well, inside of me is excited, but outside of me is also a little concerned about those things as well, because of that this type of return to the moon is being driven by commercial interests. And the way, it may come as news, but the way capitalism has worked here on Earth, the way we have really exploited the resources here on Earth, that really causes concern in terms of what kind of values we are going to bring to the moon and beyond. Because once you set up, I mean, this is a chance for humans to really set up, perhaps, that, hey, on the moon and for other heavenly bodies, we are going to bring new set of values, the values that don't prioritize profit, for example. And space offers that. The Outer Space Treaty, the only treaty that governs the outer space, and everybody signed on to it and everybody agrees to it, that is actually a very idealistic treaty. Like, it's about human. No nation can own a piece of the heavenly bodies and so on and so forth. And the plaque, the Apollo 11 plaque, and the later ones too, they talked about, we come in for all mankind. Yes, there are complications. This was driven by the Cold War, and we meant Americans come for all mankind, so on and so forth. But there is also a genuine humanistic element to it, which a lot of people subscribe to. A lot of people who are not Americans and who were not part of the Cold War in that context, they got really excited about that. And so there is this element that we can be better when it comes to space, because you cannot see boundaries from space. You cannot see borders from space. Now, if one thing that can severely undercut it, and I would say two things. One is commercial. If you go like, yeah, we come in for money. And so it's the gold rush that was, and again, people use the language of the frontier, and so it becomes the final frontier. So that is one aspect to it. And the second is militarization. And I think that we have to be very careful about, because slowly the low Earth orbit or the Earth's orbit, because of Space Force and because of Chinese, because of Russians and so on and so forth, slowly those things are becoming a little less clear cut. And then you would have moon basically become a suburb of the Earth in the space context. And so if you have military satellites here on Earth, you can imagine placing things on the moon which are Outer Space Treaty prohibits, for example, nuclear weapons and so on and so forth.
Which Putin has tilted towards wanting to do.
Right, and so did the US, right? I mean, on the moon at least, and so I think those are things that we must push. We must push now. It is not about once there is a base, what's going to happen. It's about it right now. One of the payloads right now, the commercial payload, is about cloud computing, because they think that actually this is a private company that has that on Odysseus on the mission right now with intuitive machines, because they think that you can actually store information over there, and that may be safer from hackers and so on and so forth on the moon. You can imagine some of these things being used by the military, which you won't even hear about. So I think we all have to really think about and get engaged with. I would almost connect it with the environmental movement. I mean, yes, environmental movement has been great, but it has been a little bit late. Things are happening, and then of course all of these other resistance to it that comes in. I think with space aspects, we have to get involved now. We have to shape what's going to happen rather than react to stop something from happening. I think we have to shape the way humans are going to behave on the moon and beyond.